Welcome to 206. My name is Jamal. In this particular session, we are going to look at advanced SQL. At the end of this session, we expect you to be able to identify joins, perform inner and outer joins, group selected result, conditionally select different values, change existing table, and column definitions using alter, create full text index, perform basic full text search, perform Boolean full text searches, optimize a database, perform transactions, encrypt and decrypt data. Joins are very important in our queries. Joins allows us to be able to make selections from more than one table. So if you look at our previous SQL statements, our selections were mainly based on one table. Joins allow us to efficiently query data from more than one table. An SQL query that uses two or more tables produces a new virtual table of results. We have two types of joins. We have inner join and outer joins. Normally, we use the primary key and foreign key columns as the basis to join two tables. This is a syntax for using join in our SQL statement. You have the select keyword, you specify the columns from, you specify the first table, and then you specify the join type. Either this is inner join or outer join. Then you specify the second table you are joining into. Then you specify the join clause. How do you want to join the two tables? So if you look at this table, for instance, we can make a selection from this table and this table using join. Similarly, we can make selection from this table and this table using join. So for instance, if I ask you to tell me or to display the name of people and the messages they have posted on the message forum. Searching from this table will not be enough to give you the data. It means that you have to combine these two tables so that I can get the user's first name and last name, and then I can use the user ID, which is in the messages table, as the foreign key to be able to get or query all the messages posted in the forum by a particular user. So this is a typical example of using joins in our query. So select message, we select message ID, subject, first name, from messages as M, inner join, so that's the keyword inner join, forum as F, and then we specify the join clause on the fields you are trying to use to join, and then your where clause. So you can see this is an extensive statement, but in our previous explanation, previous slide, we have discussed how to use aliases. So if you are using more than one table, using alias is very important because it allows you to be able to distinguish the fields. For instance, you could have message subject coming from two tables, coming from the message table and the forum table. So if I want the one from the message table, I would have just done m.subject. If I want the one from the forum table, then it would have been f.subject. So aliases is very important when we are using joins. Okay, so inner joint is just an intersection of the two tables. So inner joint would have brought in only the matching records. That is the records that are in table 1 and are also in table 2. So if you have forum ID in the message table and then you have a forum ID in the forum table, once this matches, then the inner join will select those records. And of course, we are further limiting the search by indicating here that the f.name, forum.name should be MySQL. So this means that we only want to display the message, that is the message people have posted, message ID here, and then the message, the subject, and then we also want to display the forum name, okay, that is F name. We want to display the forum name, but the forum we want to display is only on MySQL. The outer join. The outer join return records that don't match. So there are three types of outer joint. You have left outer joint, you have right outer joint, and then you have full outer joint. Null is returned for columns without values in outer joints. So look at this. What is happening is that, assuming this is table 1 and this is table 2, that you are applying your left join on, the left join will mean that the first table on your left, all the data are going to be returned, plus the data that is intersecting with table 2. Okay, so if you look at the results here, the example here, select f.star m.subject from the table forums as F, left join messages as M on f.forum ID equals to m.forum ID. So this is actually going to give us this data which is in table 1. In this case, our left table is forums. So we are going to have the data, all the data in the forum displayed, including the data that is intersecting with messages table. The right joint is the reverse of the left joint. The right joint places emphasis on the rightmost table. The right joint keyword returns all rows from the right table, in this case table 2, with the matching rows in the left table. And this is how we specify the query. So as you can see, from orders, we specify right joined. Then we specify the employees table. So this would have displayed all the data from employees table together with the matching records in the orders table. 3 table joins. So what we have discussed so far is about joining 2 tables. The join, inner join in particular, allows us to be able to do more than 2 joins or more than 3 joins. We can join about 3-4 tables, depending upon where the information are sitting in our database and we want to pull them together. So if you look at this query, for instance, we are selecting username, okay, from users table, and we are selecting subject from message table, and we are selecting name from the forum table. Inner, so we start with from users. Inner join messages as M, using the user ID. So we could have used where, but whenever you have the same key, which is 7 as, or the same name, 7 as a primary and foreign key between the 2 tables, you can just specify using the user ID. You don't have to use where. Then we can also specify the next join, which is inner join forum as F. We also have forum ID as the primary key and as the foreign key in the message table. So we specify using this, and then we specify the table. So obviously, you can use this one as long as you want to join the tables. But look at what is happening in this multiple join. So the first join is referencing users and messages. So this first join would have created a virtual table by joining the 2 tables. It will take the virtual table, combine the virtual table with the forum table, execute the query against it, and form the final query table. So all this, you can do as many joins as you want. Grouping results. Grouping results allow us to do summary reports. So if you want to average a particular column, or you want to determine the maximum sales, or you want to count the number of items sold for a particular day, this is achieved using the grouping results. And the syntax is on select, then you specify the function, then you specify the column within which you want to apply the function, and then you specify your from clause and specify your table. So if you look at this, we are doing two functions. One, we want to determine the maximum balance, and we want to also determine the minimum balance from the accounts table. And this, we want to be able to count the number of records in the accounts table. There are a good number of grouping functions defined in MySQL. You can go to MySQL documentation and read more about them. We, however, have to pay attention to when we are doing grouping, particularly counting and then doing group by. The keyword distinct is very, very important, because if you don't use distinct, the count is likely to count some particular records more than one time. So if you want to make sure that you count with distinct, so that each record based on a particular field is counted once, you use the distinct before that field, and that will give us our perfect count. We can also use conditions in our in our SQL. So for instance, you can give select if, then you specify a condition, and if the condition is true, we return true. If the condition is false, we return false. So we can specify conditions in our query. So for instance, I'm trying to print out a record, and in my database, I have my gender field to be M and F, but I don't want to display M and F as data to my client. So what I want to do is to make sure that when I'm displaying the data should come as male or female. I could use this conditional select cloud to do that. So here, you specify if gender equals to M, that is our condition. So if the data coming from the gender field is M, then we should specify male as the data, else we specify female as the data, and this is coming from the people's table. We're going to look at full text searches. Previously, we have used the keyword like. We've used the keyword like to be able to do some very interesting search based on text. So if you look at this example, for instance, this example uses the like keyword. So the like keyword or the like clause has this specification, which says Smith %. So this is supposed to list the records of all users who are having their last name starting with Smith. So any other characters don't matter. Once the first 5 characters are Smith, then the records will be returned. The records will be returned. So this is good, but if you are doing full text searches, this is not proper. For instance, the like cannot allow you to do the Google like searching using multiple words. So to do the type of searching like Google, or you want to implement search in your website where people can search for information within your web application, this is the best tool. So for instance, if you are a student and you want to search for a particular information on university website, you can just go to the search, which is normally at the right side of your page, and just put in any interesting keywords there and click on it, and this full text will come into action. So usually those who develop search engines use this full text technology. So you require full text searches to be able to do this kind of complex searches. Full text searches require full text index. That means that the fields you are going to be searching on must be indexed with full text. Full text index can only be created on MySQL tables. So this means that if you have InnoDB tables, we cannot do full text on them. So your tables must be using my ISAM engine to allow full text. It can only be run on a single table and not multiple tables. So if the table is not my ISAM type, we have to first of all change the storage engine. And we can do that by just executing the alter table command. So you specify alter table messages, which is supposed to be the table, then you specify the engine and the engine type. And this would have made messages table ready for full text search. Then the next thing is we add the full text index to the table. After we convert the table's storage, then after converting the storage engine of the table, what we have to do next is to apply the full text index on the table. And also that can be achieved by using the alter table command. So we give alter table, we specify the table name, we say add full text, then we specify the columns we want to apply the full text on. So these are the columns that are supposed to be in the messages table. Then once this is done, then the table is ready for full text search. So start querying against it using the match against in a where conditional clause. So this is the syntax of using the full text on our table. Select star from table where you specify the keyword match, then you specify the columns that have been indexed against the terms you want to. So look at the example here. Select subject, body from the messages where match. Then we specify the fields that we are going to search on. Then we specify against keyword, and the text we are searching will come in here after the against. Performing Boolean full text searches. A more sophisticated full text search can be accomplished using its Boolean mode. To do so, we add the phrase in Boolean mode to the against clause. And the Boolean mode operators used in making this search include the plus, minus, times. All these are the operators we use in doing the Boolean search. This allow you to add, include, or prioritize which particular word should be focused on, or the next word. So you can have range of words you are looking for, and you can prioritize which one should be more important than the other, and the searches will go accordingly. So you can read on this much more on MySQL documentation and see how they are used. So let's look at how this is used. So for instance, here, select star from table, which is the syntax. Then we specify the match, and then the against clouds. And then we need to make sure that we specify the in Boolean mode. Okay, so this will allow us to be able to do more complex searches from the text. Okay, the next is database optimization, how we can make our database run faster. First of all, you need to be aware of which type of storage engine to use. Choose the best storage engine. So if you know that you are going to be doing full text search against some tables, it means that the engine type of the table should be specified as such. And if you are not going to be doing full text search and you'll be doing only MySQL where cloud searches, then the best is to use the InnoDB. That is very fast. Use the smallest data type possible for each column. So for instance, you want to store first name, and then you say that you want 100 characters for first name. You want to store last name, and you say you want 100 characters for last name. I don't see the type of name that would consist of 100 characters. So you need to be mindful about the field size you use in your tables. Define columns as not null whenever possible. Define column as not null whenever possible. So make sure that you define columns not to be null. Okay, if you don't do this, it slows down your engine. Use integers as primary keys. Don't try and use alphanumeric as primary key or alphabet as primary key. Use integers as your primary key. Judiciously define indexes. Even though indexes speed up our search, it does not necessarily mean that we should index too much. Indexing too much also slows down your system because inserting, deleting, and updating don't like indexes because they run slower when tables are indexed. So judiciously define indexes and don't define indexes anyhow. Avoid creating too many indexes in your database. Make sure that columns to be used as the basis of joins are of the same type, and in the case of strings, use the same character set and collation. Performing transactions. Transactions allow us to be able to execute a lot of queries together. So you could have multiple queries that you want to execute, combine results from each of those queries, and then display them or do some other processing with them. So to achieve this, you have to use transactions, right? In transactions, we commit our transaction when we are successful, and we roll back our transactions when we are unsuccessful. So this is the syntax of transaction. So you give the command start transaction, and you give all the commands, the SQL commands you want to give to your transaction. So these particular commands could constitute select, insert, update, a whole lot of queries you could give within this particular section of the transaction. And then commit to, you can also add queries after your transaction failed, and that means that all those things will be done, then you roll back if you don't want other transactions to happen. So this is the structure of transactions. You can try it out later with the example stated in the exercise. Now the next thing is database encryption. Here we are looking at encrypting some fields. MySQL is shipped with some tools that we can use to encrypt data. In actual fact, the SSH1, 2, and then MD5 are used to actually represent some sort of data. They are actually not encryption tools. They are just used to represent data, reorganize, structure it in such a way that the data appear more secured. But they are not encryption. So they are one-way sort of execution. So it's more or less hashing. Once we change it, we can't come back to that. So that's one-way encryption. However, for a typical encryption, we want to be able to encrypt and decrypt. MySQL is also shipped with AES encryption and AES decryption tools that we can actually use to encrypt and decrypt data. The same as DES is also provided to be able to encrypt and decrypt. So to store an encrypted data in a table, the column must be defined as a binary type. So it could be either a var binary or it could be a blob. So take note of that. If you want to encrypt a data and store it in your database, then the field that the data is going to go to should be defined as var binary or it should be defined as blob in order to allow such data in. Okay, so to add a record to a table while encrypting the data, the query should look like this. Insert into users, you specify the full names in the table, and then you specify the data, and then the data that you want to encrypt, you have to call the AES encrypt function, and then you pass in that data here. But you have to always add what we call salt, which is just a set of characters you can dream of to sort of use as part of the encryption of your data. So this is not any special character, or it's not any special word. You just have to coin it up to support the encryption, and we call it a salt. To run a login query for the record just inserted, so let's say we want to query the records that we just insert, we need to find a way of decrypting the record. Otherwise, it will be meaningless. So in this case, we are saying that select from users where the username is the thruster that we have added, and where the pass that we are bringing, my pass is what we are bringing, and this is the data field that contains the password, and also this is the character that, or the salt, this is called salt, the salt set of characters that we added when we're encrypting the data, and then it should be equals to this. So once we're able to do this, then we can retrieve the data. If you make a mistake with your salt, then it will be difficult to return your data. So it is always good to use the hash functions to sort of represent your passwords or any other string that you don't want to reveal to the DBA. Okay, so this has brought us to the end of this session. You can read further on the topics discussed in the key text and also the links provided. Thank you very much, and see you next time.